Hello. Here we go with our next step for solving inequalities. Today's lesson is solving inequalities with one step, either multiplication or division. Before we begin, let's take a look at the properties of inequality. These will look familiar to you. You've seen the same properties with regards to equations. First of all, let's take a look at the multiplication property of inequality, which simply states that you can multiply both sides of an inequality by the same positive number and the statement will still be true. Notice I said positive. The rules do change when you multiply by a negative number. To show this, let's take an example using whole numbers. For example, 7 is less than 12, as we all know. If you multiply both sides by 3, the resulting inequality, 21 is less than 26, is still true. So you can multiply both sides of the inequality by the same number, and your statement remains true. The same is true for division. In division, you can divide both sides of an inequality by the same positive number, except 0. And the statement will still be true. In this example, 15 is less than 25. Well, if you divide both sides by 5, 3 is still less than 5. In this case, however, remember you cannot divide by 0. We can state both of these things algebraically. For multiplication, we know A is less than B, therefore A times C is still less than B times C, where C represents any real number. And for division, A is less than B. A divided by C is still less than B divided by C. Let's work a quick example, which I've actually already worked for you. In this example, 7 times x is greater than negative 42. We can divide both sides by 7 to undo the multiplication by 7, giving us the correct answer, x is greater than negative 6. To graph this, remember we're going to put an open circle on negative 6. We're looking for all real numbers greater than negative 6. Where can you find those on the number line? You can find them going to the right. Let's check our answer by checking the boundary point. The boundary point is negative 6. So we write 7 times negative 6 is greater than negative 42. All this tells us is that our boundary point or our circle should go on negative 42. Now to check to see that we've shaded in the correct direction, pick a number that is in the shaded section. 0 is here. I always like to use 0. It's there. So I'm going to put 0 in for x, and 7 times 0 is greater than negative 42 because 0 is greater than negative 42. So I have shaded in the correct direction. Looking at a division problem, we have some number divided by 3. 2 and 4 tenths is less than or equal to some number divided by 3. Since m was divided by 3, we're going to multiply both sides by 3, giving us 7 and 2 tenths is less than some number, less than or equal to some number. Now remember, you can flip the whole thing over to rewrite it with the variable on the left, and then you can shade in the direction of the arrow. This time, our boundary point is 7.2, so it's a little bit bigger than 7, right there perhaps. And we're going to make a closed circle. We're shading in the direction of the arrow. We're looking for numbers greater than or equal to 7 and 2 tenths. Again, we can check the boundary point by putting 7.2 in for our answer. 7.2 divided by 3 is 2.4. Sorry about this smart forward writing. And 2.4 is our boundary point. Pick a number. I think I'm going to pick 10. 10 is in my shaded region. And we have, let's take 9. 9 would be better because 9 is divisible by 3. So if you put 9 in here, 2.4 is less than or equal to 9 divided by 3 because 9 divided by 3 is 3. So again, that is correct. I've shaded in the correct direction. I'm doing one more example of this type because I want you to remember what to do when you have a fractional coefficient. When you have a coefficient that's a fraction, you want to get rid of it. And the quickest way to get rid of it is to multiply both sides by the reciprocal. So I'm going to write this again to illustrate that. I'm multiplying both sides by the reciprocal of 3/4, which is 4/3. I look for common factors. I have a common factor of 3. 4 times 4 is 16, so I get my resulting inequality. G is greater than 16. And my graph, I did not include, I didn't go far enough. So, but you can imagine this. We're going to put our boundary point at 16, and we're going to shade in the positive direction. We're looking for all numbers on the number line greater than 16. Now let's take a look at the properties of inequality for negative numbers. These are a little bit different. My missing parentheses up there. For multiplication, if you multiply both sides of an inequality by the same negative number, you must reverse the inequality symbol for the statement to still be true. This is our big idea for this section. When you multiply or divide by a negative number, you have to flip the sign. You have to flip the inequality sign. Let me show you why that's true. We know that 8 is greater than 4. What happens when you divide by, when you multiply by -2? -2 times 8 is -16. -2 times 4 is -8. -16 is less than -8. So we had to flip that inequality sign for our statement to remain true. The same is true for dividing by a negative number. If you divide both sides of an inequality by the same negative number, you must reverse the sign. It's our big idea. Let's look at an example. We know 12 is greater than 4. If you divide both sides by -4, 12 divided by -4 is -3. 4 divided by -4 is -1. -3 is less than -1, so notice I had to flip that sign. So that's the important thing to remember. Let's look at an example where I'm dividing by a negative number. -12x is greater than 84. I'm going to divide both sides by -12 since it was multiplied by -12, giving me the resulting inequality x is less than -7. My boundary point is -7. Put your open circle there, and we're going to shade to the left. We're looking for all real numbers less than -7. You see here where I flip the inequality sign? Let's check both our boundary point and our direction. So to check the boundary point, I'm going to put the -7 in for x. -12 times -7 is 84, so the boundary point checks. Now let's check the direction. I have to find a number less than -7 on the number line. So I think I'll pick -10, put it in my original equation, and checking the boundary point. -12 times -10 gives me a positive 120, and 120 is greater than 84. I have shaded in the correct direction. The same is true for division. Except I left my negative sign out. Let's put this little negative sign right there so I can illustrate this to you. So I'm going to start with the example. -8 is less than or equal to x divided by -3. Since x is divided by -3, you're going to multiply both sides by, again, -3. Change the less than or equal to sign to greater than or equal to, you can actually change it right here. Because we're multiplying by a negative number. -3 times -8 is 24, and we get x is greater than or equal to x. 24 is greater than or equal to x, or you can rewrite that as x is less than or equal to 24. So here we go. Let's start with let's start with 10. You only need a portion of the number line. So we're going to put our boundary point at x. It's going to be a closed circle at 24. We're going to shade to the left because the arrow points to the left, but we better check our boundary point in our direction. So the boundary point is 24. 24 divided by -3 is -8. The boundary point checks. Now let's find a number less than 24 to see if that works. Let me put in the number. Let's find the number divisible by 3. How about the number 18? 18 is in my shaded portion. So let's check that. -18, or excuse me, +18 divided by -3. We want to make sure -8 is less than that. Well, 18 divided by -3 is -6, and -8 is less than or equal to -6, so that checks. One last thing, let's take a look at an application problem. Jill has a $20 gift card to an art supply store where 4-ounce tubes of paint are $4.30 each after tax. What are the possible numbers of tubes that Jill can buy? So we have a repeated factor of $4.30. We're going to multiply that by the number of tubes. This expression represents the cost of T tubes of paint. Jill has only $20 to spend, so we have to compare this to 20. She can't spend more than 20. She has to spend less than or equal to 20. To solve this, you divide both sides by $4.30. Giving you T is less than 4.651. This is a decimal continues. Jill can buy. What can she buy? Well, she can buy 0 tubes of paint. We're thinking about what makes sense for this problem. She can buy 1 tube. She can't buy a negative amount of paint. She can buy 2 tubes. She can buy 3. She can buy 4. She can't buy 5 because this number is less than 5. So her possible choices are 0, 1, 2, 3, or 4. With your application problems, you think about what makes sense for your answer. That's all for today. Thank you.